Welcome to our channel. In the last session, we discussed insertion operations in the single linked list through Java. Now, in this session, we are going to discuss about deletion operations. So, like insertion, deletion is also performed in three ways. Delete a node at the beginning of the linked list, delete a node at the end of the list, and delete a node at any given position. Now we will move one by one. First, to delete a node at the beginning of a linked list. What are the different possible cases? While insertion, we are checking. Initially, the list is empty. Your node is the new node. Similarly, suppose if the list is empty, means it is not possible to delete a node. What is the condition for checking a list is empty? Head. If head is equal to null, means there is no element in the list. So it is not possible to delete. This is the first case. What is the second case? Assume your list consists of only one element. Assume your list consists of only one element. Simply we are deleting that element. Simply you are doing the element. Now, how do you check if your list consists of only one element? Remember, always the first node is pointed by head. If the next field of head is equal to null, means only one element is available. That means what you are doing, head dot next is equal to null. The meaning is only one element is available. Then what you are doing, simply print the data. Before deletion, print the data, head dot data, and then make head is equal to null. Then only the element is deleted. Then only the element is deleted. Now come to the case. What is the case? It consists of more than one element like this. What is the first node head? What is the step? If you are deleting this element, means in the next time after deletion, this node becomes the head node. Simple logic. So head is equal to head dot next. Simply update the head. Simply head moves to the next position. You got it? This is the way to do beginning. Now here I am opening the program. This is already discussed in the last session. Creation of a node, insert beginning, insert end, and insert at a specific position. Why? Before deletion, we must and should do insertion. That is the reason we are updating in the insertion program. Public void delete begin of. Void delete begin of. Okay. Now write down the cases one by one. Here you no need to create any node. If head is equal to null, means head equal to null, means simply you are writing one statement. What is the statement? List is empty. If the list is empty, means it is not possible to delete. List is empty, right? Now, if condition fail, here I am checking one more condition. What is the condition? If only one node is available, that means head dot next is equal to null, means only one node is available. Then what you are doing? You are printing the value. System dot out dot println head dot data. I am printing the value at that node, and then head is equal to null, means I am deleting that node also. These are the two cases. Now, else means what is the else case? More than one node is available. In this case, what you are doing? Simply print the data and my head moves to the next node. Simple logic. My head moves to the, instead of first node, my head moves to the first node. Clear? Like this, we are writing the delete begin method. Delete begin method. Now move to delete a node at the end of the list. Delete a node at the end of the list. How do you delete? Same position. First, if head is equal to null, means list is empty, you no need to delete. Suppose head dot next is equal to null, means only one node is available, delete. Now, assume this is the list. Okay, this is head. Here the aim is you need to delete this node. Okay, that is very easy. While using temp, you are have the logic. Temp is equal to head. That is, you know the condition how to reach the end of a list. The first node I assumed as temp, while temp dot next not equal to null. Here I am writing the statement temp is equal to temp dot next. Yes or no? By this, you are reaching the end of a list. Initially, this is the temp node. This is not equal to null. This is temp. This is temp. This is temp. Now, this is the temp node. Okay, fine. Simply, I am printing the data, temp dot data, and then temp is equal to null. Fine. This node is deleted. But here, what is the problem? Here, this node must be the last node. That is, this node address is changed into null. But you know this node position temp only. You got my point? That is the reason if you want to delete a node at the end, along with deleted node position, you need to store the position of their previous node also. You got the point? Okay, that is the reason. Here I am declaring one more node. Assume some PTR. Initially, I am not assigning anything. Now, what is the value? If you are not assigned anything, the value null. Now, observe first temp is equal to head. This is the temp node. And temp dot next not equal to null. Yes, temp dot next not equal to null. Inside the while loop, what I am doing? PTR is equal to temp. That means whatever the temp that is assigned to PTR. Now PTR also points to this position. And in the next step, what you written? Temp is equal to temp dot next. Now temp moves to this position. You got my point? Before moving the temp to the next position, I am placing the storing the previous address of temp in PTR. Observe in the next iteration, temp dot next not equal to null. Yes, PTR is equal to temp. This is PTR. Temp is equal to temp dot next. This is temp. In the next iteration, temp dot next not equal to null, PTR is equal to temp. This is PTR. Temp is equal to temp dot next. This is temp. Again, in the next iteration, temp dot next not equal to null. This is the PTR and this one is the temp. Now you got it? So temp dot next not equal to null, condition fail. Now the last node is pointed by temp, their previous node is pointed by PTR. Now you know the logic. What is the logic? You are printing temp dot data and mark temp is equal to null and PTR dot next is equal to null. Like this, you manually placing the null in the next field. In the next field. You got it? Now delete end. The first condition, head is equal to null, head dot next is equal to null. Everything is same here. Here, what I am doing, create one node, some PTR. Create another node, some temp. Initially, I assumed temp as head. Initially, I assumed temp as head. What is my aim? Reach the end of the list. While temp dot next not equal to null. While temp dot next not equal to null, here I am storing the previous address, that is the temp address in some variable PTR, and then temp is equal to temp dot next. I think you understand the logic. Before moving to the next position, I am storing the previous position address. Once come out of the loop, you are printing the data at last node. What is the last node? Temp is the last node. And you are making temp is equal to null. That is, I am removing the last node and then PTR dot next is equal to null. That is, now PTR becomes the last node. PTR becomes the last node. You got it? So in the else, this is while loop. This is the closing of else. This is the closing of method. Okay. And at last, what you are going to do? Delete a node at a specific position in the linked list. You are deleting a node at a specific position. I think you understand the problem. What is the problem? For example, 0, 1, 2, 3, 4. Okay. Anyway, I will create one more. So 0, 1, 2, 3, 4, assume 5. Here I given some position is equal to some 3. What is your aim? You need to delete this node. So that means to delete this node, you are have at this position. Before deleting this node, I am at this position. Assume this position is temp. Or else in the previous example like this, PTR, this is temp. What is the aim? How do you delete this one? Simply ptr dot next is equal to temp dot next and make temp is equal to null. Simple example. Suppose if the position is equal to 0, we are doing the deletion at the beginning. You got the point? Here I will write down the program as usual. Now public void delete position. Here I need to give one parameter position. Okay. Now, what is the first step? The first step is before deletion. If position is equal to 0, anyway, if head is equal to null, if you want, you need to write that one also. If head is equal to null means system.out.println list is empty. List is empty. Now, coming to else. Coming to else, within else means head is not equal to null means at least one element is available. Right now I am checking different cases. While insertion also first I am doing, if position is equal to 0, no need to traverse. Even though you are writing, not a problem. If position is equal to 0, simply you are writing delete begin of. Yes or no? Automatically you are deleting the node at the beginning of the linked list. If case. Now here else else in the sense position is not equal to 0. Here what you need to do, you need to reach this position along with, suppose I am given some position is equal to 7. What happened? That 7 is not available means first thing is you need to check whether the position is available or not. If the position is available, then only you are doing the operation. For such purpose, I am using some flag variable. I am using some flag variable. What I am doing? Observe int some x is equal to 1. Anyway, you will understand, not a problem. Int some x is equal to 1. Node some temp is equal to head. Node some temp is equal to head. Okay, the first node I assumed as temp node. Now what is the step? You need to reach the position. For int I is equal to 0, I less than position I plus plus. I less than position I plus plus. Here same logic, ptr is equal to here. Before this only I am declaring some nodes. Node ptr, node temp is equal to h. Okay, already head is declared here. You can declare it anywhere. That is not a problem. Okay, so ptr is equal to temp and then temp is equal to temp dot next. What is the logic here? Here in the deletion at end, we are written some logic, exactly the same logic. Exactly the same logic. But previously you are reaching the end, but in this case you are reaching up to the position. Up to the position. That means if this is the element you want to delete, this is the temp node, this is the PTR. Now, here when the loop is completed, here two cases are available. The first case is whenever my position is available. Suppose I given position is equal to 3. My position is available. That means this loop is completed. We are coming out of the loop. One more case, if position is equal to 7, the loop repeats so on. But there is no temp. Temp is equal to null. You got it? So that means while moving, you need to check the condition like you are doing insertion. If temp is equal to null, temp is equal to null, you are written one message system.out.println. What is the statement? Position not found. Position not found. You need to write that message. After that, what I am doing? I am updating the value x is equal to 0, and I will write down some break statement also here. The if is closed and then the for is closed. Now understand the concept. Initially, x is equal to 0. Assume I given the position is equal to 3. Now PTR is equal to temp is equal to temp2 next. This if condition is not at all executed. Why? I have total fifth position. My position is 3. So temp is not equal to null. The if condition is not executed. We are coming out of the loop by the end of this loop. If you are coming out of the loop because of this case, what happened? Because of this case means this is not executed. If this is not executed, in the sense it is possible to insert. How can you say that? For example, if position is equal to 7 means I less than 6, but at the fifth position, temp is equal to null. We are coming out of the loop. While coming out of the loop, I am changing the x value into 0 means, now understand, if x is equal to 1, what is the meaning? If x is equal to 1 means, I am not enter into the if. I coming out of the loop because of the position availability. If x is equal to 0 means temp is equal to null. Clear the point? If x is equal to 1. Now, you know the logic. What is the logic? PTR dot next is equal to temp dot next. PTR dot next is equal to temp dot next along with print the data. Whatever the data that is available in the temp, print the data, close the if. This is a closing of. Now observe the brackets carefully. So this is the position is equal to opening of else. This is if condition. For if this is one else, this is second else. Now ob dot delete begin. Ob dot display. Ob dot delete position 2. Ob dot display. Ob dot delete end. Ob dot display. Right? Now save and go to the command prompt. Already insertion anyway, execute one more time. So PTR might not be initialized. Okay, no problem. Observe where PTR is available here. Variable PTR might not have been initialized. PTR dot next is equal to temp dot next. Now in this example, where here at this, if x is equal to 1, PTR dot next is equal to temp dot next, everything is fine. Now here I am declaring one node. The node is PTR. Understand carefully. Node PTR. I am declaring one node PTR. Initially, PTR is equal to null. Even though you are not given, that is not a problem. And initially, temp is equal to null. Then also not a problem. In that case, here you are writing temp is equal to h. Here you are writing temp is equal to h. That's not a problem. Temp is equal to h. This is the position. I equal to 0, I less than position. PTR is equal to temp. Temp is equal to temp dot next. While coming out, if x is equal to 1, PTR dot next is equal to temp dot next. And then we are printing the data at temp. Save. Now, one error. Here, one more place. PTR dot next. Here, where? At delete end. Yes, here. Here, the problem is I declared PTR inside the else. I declared PTR inside the else, but here I am using the PTR outside. You got it? That is the problem. Now, here one more place that is available. Check where it is. In the first delete and beginning, there is no problem. And here node PTR is equal to null. First if case, head case, that's not a problem. In the else case, node temp is equal to head PTR. While loop is completed. temp is equal to null. ptr dot next is equal to null. Now, clear. Okay. Now observe the cases carefully. What I am doing? First I am doing insert operation. 30, first to 10 is inserted, before that 20, before that 30. So by display 30, 20, 10. See this one? 30, these are insertions. This is display 30, 20, 10. Okay. After that 100 is inserted, followed by 200 at the end. So 30, 20, 10, 100, 200. Now at position number 3, 300 is inserted. At position number 3, 300 is inserted. Clear? 30, 20, 10. Right? Now what I am doing after display, delete element at position, delete at beginning. So 30 is deleted. Observe here 30 is deleted. Right? Now delete at position number 2. At position number 2, what is the value we have? 0, 1, 2. So 300 is deleted. Observe 300 is deleted. Now at position end what is the value? 200. So observe 200 is also deleted. You got it? Like this, we are doing deletion operations also in single linked list. That's the end of today's session. Thank you.